The mic is yours to bring your panel up and introduce them. You know, we all have our crosses to bear. Thank you very much, gentlemen.
As they're all coming up on the dais, I was thinking back to the previous panel where they were commenting about the difficulty of doing this a panel right after a very good lunch. I might counter that I would submit to you that this may be the more difficult panel because we're the last impediment between you and the bar this afternoon. So we've got 1 hour. My plan is for 10 minutes per panelist, and that should leave us about 10 minutes for Q&A thereafter. First up this afternoon is Mike Bowen, who's the Director of Attack Helicopter Sustainment at Boeing. The Attack Helicopter Sustainment provides a full range of innovative products and services to optimize the readiness of aircraft that are fielded throughout the world. He's responsible for executing the U.S. Army Integrated Logistics Support Business for the AH-64 Apache, the AH-6I, and the Mission Enhanced Little Bird. Mike has more than 35 years of military and private sector experience, including 22 years in the United States Air Force. We seem to have an Air Force men here this afternoon. So Mike, I'll turn it over to you.
Great. Thank you very much. On that theme of speaking about my past in the Air Force, I did want to send a message to General Gabram here, since he's here, is that, we do operate under the art of the possible in the Air Force. And just to demonstrate the intersection between the art of the possible and the partnership that we feel with CCAD down here, I was just wondering if it would be possible if you would give me your drink ticket for the happy hour that's about to happen. So just a shot in the dark. If you go to the next slide, please. We're super proud to be a member of the CCAD team down here. We have several dozen Boeing employees that have been down here. We've been part of the team for almost 2 decades down here. And we want to certainly thank the Quad A for inviting us down here. And also, we'd like to give a shout out, even though he's not here, to Colonel Lancetta, who's been a great partner with industry. And we certainly appreciate his participation with us and his whole team. You know, to keep these aircraft flying, obviously, we all know it's a team sport. It takes a great industry government partnership, and boy, that sure is, we can sure feel that down here at CCAD, working with everybody. We know that it's our job to work with our partners down here at CCAD to increase the operating time of the Apaches and the Chinooks. And so, anytime there's a crash battle damaged aircraft down here, we try to help the government team down here restore that flight status as quick as possible. In addition, because we're the OEM for Apaches and Chinooks, we have basically in our factories back in Mesa and Philadelphia, we have a depot repair and overhaul capability because we build the aircraft there. In Mesa, we also have a depot repair and overhaul capability in Philly, and we actually have recently stood one up in Riyadh, Saudi Arabia, to deal with the many aircraft that the Saudis have bought. And so, one thing that we have offered to CCAD is that we have the sustainment expertise on a lot of these things, and we work hand in hand with the CCAD folks here, to try to transfer that as much as possible. We do that in the form of some commercial services agreements. And in addition, we do it in the form of benchmarking visits. And so we've invited a lot of the CCAD directors up to Mesa and Philly and taken them through the production lines and shared as much of that as we could. And then finally, we get that our mission is the bottom line, support the warfighter and the soldier. We understand that given the world events that General Gabram spoke about earlier, the importance of what CCAD does is probably more important today than it was yesterday, and it'll probably be more important tomorrow than it is today, given where this looks like it's going. If you go to the next slide, please. Our role in the Army sustainment, we certainly have enjoyed the last 13 years in a TELS partnership with CCAD. We also operate a performance-based logistics contract for the U.S. Army deployed worldwide. We've done maintenance augmentation teams to help countries and units get up to speed on how to maintain Apaches and readiness and increased readiness levels. In addition, we're in the process of trying to usher in basically 2 new weapon systems, which are the Echo model Apache and the Block 2 Chinook. Anytime that you bring a new weapon system like that in, you're going to have growing pains. We're feeling them now. We're trying to work with our government counterparts to navigate through those. But with the idea that we know what we're doing today is going to benefit the 70% of the weapon system cost that's on the sustainment side of the equation, and we take that to heart and try to save the Army as much money as possible. And then finally, when we talk about the surge capability, everybody's talked about that today. It's tough to do when you don't have a significant emotional event like a war going on, but we get that we got to get the inventory levels up. We're going to work with our government counterparts to try to figure out how to do that in the most economical way. And obviously, we're looking at a long-term win-win partnership with the Army, because the Army has to decide with what its priorities are and when where they allocate people and resources, and Boeing does the same thing. We have to decide, and we've put a whole bunch of folks down here that are here solely to help the CCAD team do its mission. And then I want one final shout out for those of you that know Crystal Rice, who's been the leader of Boeing down here at CCAD. She's got a great opportunity to move on to a new job. So when you see her at the cocktail hour, wish her well. She's going up to Oklahoma City to take a great job. And frankly, most of the Boeing leaders that have been down here running the CCAD operation for us have moved on to really cool, better jobs. My final point on the last slide is that, I know, if you go to the next slide, please. We get your charge, General, to fight tonight. One thing is that, when you're at home tonight and you're looking at your iPad and you're shopping on Amazon and your iPad mysteriously breaks, what do? You go to Walmart and you buy another one. Okay, we build combat weapon systems. That's not an option. When they break, they got to get fixed ASAP and back in the air. So we're in a different game. We got to think a little bit differently. We got the sense of urgency. And so, again, appreciate the opportunity to talk to you. Boeing's in this for the long haul, and we look forward to the next 15 years.
Thanks, Mike. Just to qualify, when General Gabram's iPad breaks, he calls his aide and says, "Get me a new one." Next up is Harry Nahadas, who serves as the General Manager of Turboshaft and Turboprop Programs at GE Aviation. He's been employed at GE for over 30 years on a variety of assignments in engineering, business planning, and market development, marketing, and sales, as well as project management. Harry's worked on military and commercial engine programs from Cincinnati, Ohio, to Lynn, Massachusetts, to Egypt and Athens, Greece. Harry, the floor is yours.
Thank you, General, and thank you for inviting me to participate in the panel. General Munt, thank you for hosting us at Quad A. This is my first Luther Jones, so I'm really enjoying this conference. I'd like to talk about 3 things today with regard to the future of engine sustainment. The first being enabling fixed-forward capability, the second, improving time on wing, and the third, partnering with the depot. So first, enabling fixed-forward capability. And all 3 of these areas are ways we can improve readiness and reduce maintenance cost. So enabling fixed-forward capability, we do that through simple modular designs so that you can have cost-effective repair in the field. And for the future, one of the key technologies that we're bringing forth is improved troubleshooting and condition-based maintenance. So it's not good enough just to be able to fix it forward. The engine needs to tell you what's wrong with it. And so that's where we're heading in the future, engines will be able to say, hey, change this module, or change that module, change that LRU. That's the future of fixed forward capability. And then lastly, of course, you still need to tailor the design of the engine for ease of maintenance. And so where you place the LRUs so they're most easily changed is very important, and we're becoming better and better at using data to determine that. And so those are three key areas that we're working on to improve and enable fixed forward capability. And at the end of the day, it's all about improving the readiness and reducing cost. So if you can swap out a component in the field without sending it back to the depot to do a complicated repair, that gets it back in the aircraft and the aircraft back flying, able to do missions faster. Second is improving time on wing. And we do this by inserting technology into the engine. So things like improving the sand tolerance of the engine so that the engine stays in the aircraft longer. So we have better inlet particle separation, advanced design features to not allow the sand to get into the internals of the engine and clog things up. So sand tolerance is a key. In the areas that the Army operates, sand tolerance is a really important factor. And so we're paying a lot of attention to that. So future engine designs will have even better sand tolerance than the ones that are currently fielded today. Second, of course, is improving the temperature margin so that the engine is able to deteriorate for a longer time and stay on wing at a longer time. So we do that with better materials, for example, better cooling technology, better efficiency in the components of the engine. And so we focus a lot of our technology on improving the temperature margin of the engine so that it stays on wing longer. Third is improving the reliability of the engine. And really, one of the key things to improve reliability is to have a simple, rugged design with fewer parts. The fewer parts you have, there are fewer things to break, and therefore, there are less time between failures. So high reliability is another factor to improve time on wing. And then lastly, of course, is improving the life limits of life-limited parts. So rather than having to change a life-limited part every 2,000 hours, maybe now it's every 10,000 hours. And so that virtually takes life-limited parts out of the equation with regard to maintenance. And that's a key factor in reducing the cost of maintenance. So fewer engine removals, improves readiness, and also reduces cost. The last thing I'd like to talk about is partnering with the depot, and most appropriate for being here in the shadow of CCAD. And the key things that we work on with the depot are reducing turnaround time. More accurate, a lot of discussion has happened with regard to forecasting and working closely with the depot to improve forecasting, and that is a key factor in improving the turnaround time is more accurate induction forecasting so that we know what parts the engine's going to need before it shows up at the depot. And then when it shows up at the depot, it's really cost-wise work scoping so that you're not changing every part in the engine, you're changing just the parts that need to change in the engine to optimize how long that engine stays on wing. And then lastly, sharing best practices to improve turnaround time. We have a number of depot shops ourselves, both commercial and military all over the world, and we've developed and collected a number of best practices that we very willingly share with CCAD to help improve the turnaround time. Right? And of course, improving turnaround time then requires less engines in WIP, therefore you have more engines available as spares to improve readiness of the fleet. Second, with regard to depot partnering is developing data-driven repairs. And that's really about looking at the leading indicators when an engine comes off wing, it goes into the depot, gets work scoped, recognizing using statistical data what parts are falling out, I'll say, above average amount, and therefore targeting those parts to develop a repair so that you can quickly turn around those engines, save money by instead of buying brand new parts, you can repair a part, put it back in the engine, and have it essentially as good as new. The data also helps you prioritize the repairs so that you know I'm going to have 50 engines coming in another 3 months with the same problem. We can start prioritizing, well, we better get a repair underway for that particular problem so that it's ready when all these engines come in. And then lastly, enabling a smart buy versus repair decision so that the depot is not unnecessarily replacing parts, that they're using a cost-effective repair instead. And then the last thing in terms of the future that's coming is what we call Brilliant Depot. And essentially that's modeling all aspects of the depot so that you can better optimize the workflow through the depot. You can improve the scheduling through each of the stations in the depot to optimize so that no station is underutilized and no station is being a bottleneck. It allows you to plan your maintenance of your machines better so there's no downtime of the machines. And then lastly, doing all that improves the capacity, not just incrementally, but through really a leap ahead in terms of how much capacity now you can put through the depot with a more efficient operation. So really, from our viewpoint, partnering with the depot drives down costs and increases depot capacity. And those are the three key areas with regard to readiness and cost that we're focusing on for the future. Thank you.
Harry, thank you. Welcome to your first Luther Jones. In fact, I think you did so well. I think Greg Gass is out there already planning your return trip next October. Speaking of return trips, pleased to welcome again Rod Hines, who has led Honeywell's U.S. Army business and is Honeywell ambassador to Huntsville. He's a 1993 graduate of the U.S. Air Force Academy, subsequently saw the light and was cross-commissioned into the U.S. Army. Rod served over 20 years in various leadership positions in Army Aviation, commanded all the way to the battalion level, and has 6 operational deployments, 4 of them in combat. Rod, welcome back again, and I'll turn it over to you.
Appreciate it, sir. General Schlosser, General Gabriel, General Munt, appreciate everybody out here. I, for one, was not happy that the Yankees won yesterday. Ate my dinner, came in late last night, went to the bar, ordered my dinner, and I was positioned in this giant screen, had the Yankees playing the entire night, and then they ended up winning 8-4, which kind of put a sour note on my otherwise really nice meal. But regardless, you know, we're real close to being able to use our chit to go to the bar, so I'll get after it. You know, I reached out to some colleagues and staff, you know, give us some ideas on a future panel from Honeywell on this, and they, God bless them, but they gave me like way too many slides. So I cut it back significantly, but I'll rifle through them very quickly so we can get on with the rest of our afternoon. So agenda, I'll brief overview of platforms that Honeywell supports. And then I want to go into like 2 areas where, you know, from a future point of view, things that could potentially help make operations faster, quicker, better at a depot, at a place like CCAD. One, I will admit, is probably more evolutionary in nature, and the other one is probably more revolutionary in nature. And then we'll take questions at the end. Major platforms supported. Bottom line is Honeywell's got various APUs, engines, generators on every Army aircraft, fixed wing included, and then of course we're on virtually every major ground system to include the M1 Abrams tank. Biggest ones by far the T-55 engine, which everybody here at CCAD knows very well, and also the AGT 1500, which powers the M1 Abrams tank. So one of the unique aspects of Honeywell is we're essentially a commercial company. Probably 5%-ish of our business is really, you know, strictly DoD. So what that allows us to do at times is to kind of leverage some technologies, applications from our commercial side and see how they can support the military. I'm going to go a little bit about this Vocalec voice technology piece briefly on it. I'll tell you, I'm not an expert on it. At the end of the day, as it was pointed out, I'm really just a simple gun pilot. So if you have questions at the end, please don't make them too technical. So what is Vocalec? So essentially what Vocalec allows you to do, it's a hands-free system which allows the maintainer, the inspector, to, through a voice command and also linked to a server, allows them to get instructions on how to do inspections, a PCMS, a induction, all hands-free and all to standard. So at the end of the day, what does this do for your process? Well, it increases your quality by reducing mistakes that are executed. It increases your speed and efficiency of doing the inspection or the process, and it's also safer. And then it also reduces complete manual entry as well. All right, so where's this being used? Well, our sister services are using it. At Blunt Island, the Marine Corps is currently using it to do PMCSs on a couple of their platforms. And what is found to have done is reduce the time to execute a PMCS by 72 minutes. It's increased the proficiency by 42%. So one little aspect of this, not to get into too much detail, is like if you're doing the inspection and you discover that part X is broken, you can automatically order that part while you're on the vehicle, and it'll immediately go to the warehouse and through the system, SAP system, and get that part on order for you, and it's all documented. In addition, it's being utilized at Hill Air Force Base, doing induction inspections for auxiliary power units. One aspect there I'll just kind of hit on is the accuracy of the entries is at approximately 99.9%, which is pretty good. Manually, it was at 88%. So what does that do? At the end of the day, it saves you time. And the Air Force was able to, on these inductions, get it 23 minutes faster and 30% increase in productivity. And from what I understand, with the APUs was like a test bed at Hill, and they're looking to see where they can expand it to other areas. So again, you can see some of the metrics there, and it is utilized across other functions or entities like Nike, Lufthansa, Amazon utilize it for some of the, and Ford as well. And the one thing I kind of like when I first heard about it is, well, does Honeywell use it, you know? And the answer was yes. So that was actually kind of good, because how often you have things that, you know, your own parent company doesn't actually utilize. So again, this is like a summary of some of the advantages on how it can help operations. I think one of the other areas that shouldn't go unnoticed is supervisors on the screen can actually monitor what Private Hines is doing out there on the flight line or in the hangar, and really be able to monitor and see whether or not Private Hines is where he should be on that inspection, if he's going slower, faster, and whatnot. So Hines may not like that, but the NCOs and leadership may very well. The other aspect of it is quite utilized heavily in warehouse operations for very obvious reasons in terms of picking and choosing on that. I told you I was going to go fast. And now the slide was up, big button. Okay, the next one I'm going to transition to is one that Honeywell and quite honestly a lot of industry is getting very well engaged on. That's additive manufacturing or 3D printing. I would tell you that this is the technology that when you're looking long term in terms of how it could really improve futures in terms of sustainment and supplyability, this one's probably got, in my opinion, the greatest potential. But when you look at the technology where it is now and where we are as an industry, I kind of relate it back to where the internet was probably in 94, 95. People are recognizing the capability, the potential, but it's not quite there yet. So the question really is, does it make a evolutionary leap like the internet has done in all our lives during that time period, or is it more incremental? And that's probably more to be determined. When you look at, you know, the aspects of additive manufacturing and aviation and the parts that it could potentially make, and I didn't put the parts up there to kind of keep this brief, but systemically what you find is that process reduces your lead time by 90%, and it also can reduce your cost for that individual part by 90%. So those numbers should speak very, very loudly of where additive manufacturing could go to when you look long term on whether it's a depot or out conducting maintenance out in the field. Because no longer would you potentially need to have large warehouses, but then all you need is the machines to be able to, and the raw materials to be able to manufacture it. So again, this timeline is kind of like where Honeywell's aspect of additive manufacturing has been, and as you can tell, since you're only going back 10 years or so, it really is at the infancy stage of it. But I can also assure you that industry is spending millions in developing this technology and developing the TTPs associated with it. Now, it's not a panacea for everything. I mean, I'll be very honest. I mean, there's some challenges even at this early stage of additive manufacturing. First and foremost is, can you make airworthy components, right, in a safe manner? The other piece of it is the tech data rights aspect of it. Industry, it's like everybody on the panel, spends hundreds of millions of dollars, billions, if you will, developing, designing, building, producing aircraft, engines, components, you name it. That tech data right piece of it, well, the advantage of the Army would be if they had it, they could then be self-sustaining through an additive manufacturing product down the line. So, we have to work through that, right? I mean, because there's going to have to be some sort of balance associated with how the Army or the Air Force, whoever, utilizes those tech data rights to be able to leverage it in an additive manufacturing process. But, I'll also tell you that even at this early stage of it, legacy systems, legacy components that the Army does actually own, the tech data rights, this is something you can almost leverage right away. All right, this is a slide that the rest of the staff wanted me to brief. I'm not going to brief it. Bottom line is, I only picked 2 examples of future areas where you could potentially see the advantage in a depot level area, but there's also other areas that we're all striving toward to improve readiness across the fleet from the Army. And then finally, I'll just tell you that, at the end of the day, I tell my folks that our report card's written by that trooper on the ground, and if we do that right, the rest of it usually takes care of itself. So again, I want to really thank CCAD, the leadership, Mike Boyce, my team here from the TELS contract for everything they do down here. You guys got to know that you're a national treasure and of strategic importance to our nation and our Army. So thank you very much.
Thanks, Rod. Sorry you couldn't digest your dinner last night. Really makes me feel bad. Not. New to our panel again this year is Jeff Hankey. Want to welcome him. Jeff, since January 2015, has been the Director for Army and Air Force Programs for Sikorsky, now part of the Lockheed Martin Corporation. This program includes new production for U.S. Army and foreign military sales for the UH and the HH-60 Mike. It also includes aftermarket support for over 2,500 helicopters across the Army, Air Force, Coast Guard, FBI, and numerous foreign fleets. Jeff has served in a variety of increasingly responsible positions in the United States Navy as an SH-60F and HH-60H Seahawk pilot. Jeff, welcome, and I'll turn it over to you.
Thank you. And Generals, thank you for inviting me, and happy to be on the panel today. I did want to start with this photo. I wanted to start by saying thank you to everybody who did our little part to make sure that the helicopter lived up to the potential that our founder, Igor Sikorsky, was very proud of saying, and that was saving lives. And you heard earlier today from the Air Force gentleman that said it was 115 or whatever for the Pave Hawk with the Army ones, the Navy ones, and everybody else who was in there. And there's thousands of people today across Texas and across Florida that are happy to be alive because the helicopter was available. And frankly, the folks in this room did a part to do that. They did a part to sustain these aircraft, build these aircraft, and maintain them. And some of us have personal experience flying them. But I'll tell you, it's a no better feeling than to show a small child up there that he's going to be safe for the night right there, and he doesn't have to spend his night on that roof with the flooded front yard. That last slide was for my lawyer, so I'm going to skip that one. So we really do 3 things that I want to share with you here at Sikorsky to improve readiness and reduce costs to the Black Hawk. First and foremost is our FRACUS effort. And the FRACUS effort is an incredibly technical deep dive into why parts are coming off the aircraft. So here's a Pareto of all the parts on an H-60 and how often they come off and what they are. And I'll walk you through the tail wheel lock pin for an example. That's a surprising part to have that high up on the list, isn't it? You would think dynamic components would be up there. And you have to take a deep dive into looking at the findings of why these parts are coming off an aircraft and what is driving cost. And this is driving unscheduled maintenance in the field. So an operational impact as well, right? So we had a dual issue here. We had an issue with the supplier bushing installation as well as maintenance-induced issue. And frankly, if you happen to have the pin locked and you try to go taxi around, you can bend and break it. I've done a few myself. So, but that's part of the reason of the root cause, is to dig into every one of these removals and find the commonality. And unfortunately, a lot of these removals are written, in different ways. So you have to use some tools, you have to use some big data, some analytics to figure out, wordsmithing, finding out what's going on and draw quick conclusions on why these parts are breaking. And then you need to go to a corrective action pretty quickly. Because a lot of these things, corrective actions, if it's a lead time sort of deal with an engineering change, if it's a lead time sort of problem because there's tooling that's required, or you have to go find a different supplier to make a part for a different quality issue, it can take a long time. And then if it's even a training issue, if it's something you have to feed back into a very broad fleet, I mean, we have 2,135 Blackhawks in the Army. That takes a while to train folks out there. So data is a big, big resource toward finding out the issues that are driving cost and readiness issues. And we have a lot of tools to do that, and frankly, FRACUS is a good one for us. And this has led to hundreds of engineering changes going forward to improve parts, make them more reliable, and keep them on the aircraft longer. Another thing to do is to look into parts. So we do this, here at the depot. You're looking at parts that, for one reason or another, are coming off way earlier than you would expect them to come off. So then you have to look into it. This is the main rotor shaft extender. It's that large silver cylinder in the middle on all the Blackhawks. It's a very complicated part to make, surprisingly enough. It looks simple, but it's a very long lead part to make, and they're a very expensive part to make. So if there's an ability to harvest some of the ones that are coming off by looking at field data and usage and fatigue tests, maybe do an extra analysis, a little bit of testing down in our lab at Sikorsky, and be able to open up some of the tolerances on some of these parts in certain areas where some of these parts can be harvested again and returned to the fleet quickly. Main rotor shaft extender right there takes longer than a year to make. So if you can find a way to salvage one that's already been there and damaged just slightly beyond the limits, if there's a way to engineering justify that it can be used, you can get it right back on the aircraft, you can get it right back into the fight a lot quicker than going and buying a new one. And additionally, it's less cost. And finally, we're working with AED on time between overhauls. So UH-60M, as you continue to use it and get more data and usage data, start to understand how the loads are and spectrums are used to the aircraft, you can do an analysis of some of the dynamic components and see if your time between overhauls are set correctly or if they're too conservative. And some of these, we took a look at 6 of these parts, and a lot of the regime recognition is frankly not as severe as we once thought. So there's a process going forward now to identify these 6 components and where you can increase the time between overhauls. And that increase in the time between overhaul not only increases the time on the wing for the unit in the field, so they don't have to do a removal, but it also reduces the number that have to flow back here through CCAD, and so therefore keeps more units out on wing. So it's a win-win. Those were my 3 charts.
Jeff,
If anybody has any questions, you can get them at the end of this.
Jeff, thank you very much. I've noticed that the panelists are staying right within the time constraints that they were provided. I do think the threat to collect your free drink tickets has definitely been an implementer here to keep us on time. And last but not least, our final presenter has assured me that he is 9 minutes or less and to get us to Q&A. Joe Ash is down there on the far end of the table. He currently serves as Director of Business Development for Customer Support Operations of Parker Aerospace, and he's responsible for Army sustainment programs. He has over 35 years of experience in the aerospace industry, working support and sustainment for the last 28 years. Joe, welcome.
Oh, thank you. It's a pleasure to be here and kind of an honor to be here. This panel brings with it quite a bit of experience and knowledge, as you can see, and I will be within my 9 minutes or I'm going to lose my drink ticket, so, so I'm going to have to fly through this. I'm looking at it from a little bit different perspective. We are responsible for hydraulic, pneumatic, and fuel components on all the aircraft that a lot of these different companies make and produce. We have our components are on everything the U.S. military flies, and of course on all the aircraft that have been mentioned today. We kind of look at it as two different things. So when I was first thinking about this panel, I was thinking about how do we, for the future, look to say, how can we reduce the life cycle cost? So what we've been focused on for a number of years is how do we reduce the life cycle cost from both a sustainment, but also from a hardware point of view. So the sustainment and the product improvements kind of fall into two different categories. But both of them utilize either new technology, processes, and or business models. So we look at it all to say, how can we lower the cost overall? You know, when we're looking at this as a defense industrial base, whether you're government or contractor, really we're facing a dilemma. We do have a burning platform. We have increasing threats out there. Who would have thought, 3-4 years ago that we would have been looking at this with North Korea like we are today? Who would have thought that we would have still been over in the Mideast? So there's, these missions that have to be done, but we have to balance that against our federal budget. So the federal budget constraints are not going to lessen. They're going to be there, and so how do we do this as a balance? So that creates a burning platform driving us to change as an industry, and I'll call it a defense industrial base, both government and industry. So we have to provide solutions that improve the performance, and however you define that performance, but really when you look at it, out there in the field, out there to the warfighter or the soldier, it's really talking about reliability, can I do my mission? Availability, is it there when I need it? And logistics footprints, how much do I need to bring with me? Life cycle cost, we always, when we're looking at any of our solutions, we always consider life cycle cost. You can't look at the short term, the interim solution. You've got to look at it holistically. It's got to be this long-term approach looking at cost. So we developed a strategy quite a few years ago, and we looked for those end user unmet needs. And we had numbers of different types of resources, different types of information, and many of the panelists have already mentioned those, but whether you're looking at end user data, field data, whether we're looking at the depot data that we see when items come in for repair, or whether we're looking at OEM data. And what I really mean by that is the new programs that we're doing, the new helicopters, the new fighters, the new processes that we employ with this, because all of these programs are fairly old. We always look at all the stakeholders. You've got to consider not only the warfighter first, the warfighter always, but you also have to consider the buying command. You have to consider ACC, ALC. You have to look at all of the stakeholders involved. And really it's saying, can we provide improved sustainment at a lower overall cost? Maybe not a lower instant cost, maybe the contract cost is a little bit higher, but does it lower the cost overall? Going to a hardware-centric approach, a product improvement, we've established a formal process that identifies those product improvement needs, like was mentioned in the previous slides, and it's really done through numerous collaborations. So we have to collaborate with our manufacturing folks, with our design engineers and everything like that. As the OEM of these products, we look for technology insertion and or technical feasibility. So can we incorporate this new technology into these old products to bring them either a longer life to them or lower cost? And then we also look at our manufacturing processes. How we manufacture parts today are vastly different than how we did 20 years ago. And as was mentioned earlier, with additive manufacturing and some of the new processes, I'm sure it's going to be a revolutionary change in the next 20 years. So we have to look at all of that, and then we have to evaluate and prioritize those opportunities. First and foremost, you look at what is the customer's needs out there. What is that unmet need that the warfighter needs and or the buying command? And then how do you coordinate across everybody? And then, of course, once we do that, we coordinate mutually. It's not something that we, as Parker, say, gosh, this would be best for us. We say, what's the best overall as a balance between the warfighter needs, the buying command's needs, ALCs, ACCs, as well as Parker's needs. And then track those opportunities and bring them to fruition. Then as far as the process-centric, I'm going to bring up partnering. We're just starting partnering on a secondary item repair, the hydromechanical flight controls for the Black Hawk helicopter and the hydraulic power unit or hydraulic pump also for the Black Hawk. We just signed the contract this past summer, and we're ready to induct our very first units, hopefully within the next few days, next week or so, and those will be going in. Really, and when we set it up, Colonel Lancetta's team, Bob Straighton, and everybody has been absolutely fantastic to work with. We were able to get this partnership done in record time, and how we did it in record time is we had a real team approach to it. The focus for all the team members, whether it was contracting, whether it was logistics, whether it was the sustainment folks, the depot folks, or Parker folks, the focus was always on how can we improve the support to the warfighter? How can we increase that reliability and that availability of the parts out there for the same or lower cost? So we looked at what is impeding these repairs. A lot of times it was parts and data. So that's what we really focused on, was how do we set up a relationship that's symbiotic for both the depot and Parker, and we really look forward to this. We have numerous partnerships across the DoD at all 7 of the depots. But we really believe that this partnering is going to bring better support, better sustainment at a lower overall cost. And that's what I think the future looks like for us all. Looking to the future, what's missing though? So getting to these points has been different, whether we're talking with the Air Force, the Navy, or the Army. There's really not a disciplined or repeatable process across the DoD. So how do we get to a repeatable or standardized process for sustainment across the DoD? And it's very easy to point, well, the DoD isn't standardized, the DoD hasn't done this. I think as industry, we've got to also hold ourselves accountable. As industry, are we bringing the best overall value to the government, to the warfighter, to the taxpayer? So I think we, as industry, have to hold our hand up and say, are we accountable? Are we bringing the best value? And then the last real thing is there a linkage of goals across all the stakeholders? Many times the goals of contracting are very different than the goals at ALC, which are very different than the goals of the depot or industry, very different than the warfighter. So how do we align those goals? And how do we get the linkage to those goals? I think really, it's really creating that culture of, in all decisions, looking at total life cycle cost, total cost of ownership, whatever you want to call it, whatever acronym you want to use. And I think the more we can do that, the better off we'll be. Forums like this, I think, give us a great opportunity to exchange ideas and get industry, government talking together, get government talking together. So I really think forums like this, Luther Jones, help, and we should probably try to do more in the future. And with that, am I under my 9 minutes?
You did good, Joe. You know, I'm thinking, as I was listening to all 5 of the presentations, that the importance of relationships cannot be overstated. And I think what you've heard from these 5 representatives from these OEMs has demonstrated that they have the competence, the capacity, and the commitment that's indisputable to meeting CCAD, meeting AMCON, and meeting actually Army writ large strategic objectives to reduce costs and improve readiness. And I think that was a consistent message throughout. I think the other consistent message that all 5 articulated is that they are there to support the soldier and the warfighter, and I think that's absolutely critical, and I thank all of them for their effort this afternoon. Let me open it up to questions and answers.
No, Joe, Gabriel's got some questions, but I'll give you guys a shot first. Here we go.
Dan McDonald, Knowledge-Based Systems. Mr. Hines, you made comment about using the voice-to-text information in your commercial side, which you're looking at bringing over to the government side. And Mr. Hankey, you talked about using your system, do a deep dive, and I forget the name of, go back and look at why parts fail and why they come off the wing. In about 2003, 2002, we instituted a controlled natural language process with PSA assembly for aircraft in CCAD, using drop-down menu sequence of entering data on specific fields in a specific order and whatnot, but still gave them free narrative. Have y'all had any experience at all with using CNA to standardize and make clear the information you're trying to collect in either your production lines and/or your analysis line for defects?
A lot of the defects are standardized with defect codes, et cetera, but not, some of it is still text mining. Some of it is still, if a soldier writes up a discrepancy one way versus another way, you still have to go in and see if, and doing some analysis as to how the way it's written. But there are standard codes too, so you can do some queries off codes.
I'm familiar with the codes. I guess my point would be something more along the lines. There's various ways of writing corrosion down that any particular soldier might decide on that particular day. Rust, corrosion, delamination, scratches, marring, they could all be in exactly the same thing. Is that what you're using for your word mining, or did you all come up with a process by which you can only use certain phrases in a certain sequence to define a certain product, and there's no deviation from that? And I'll give you an example of that. Is anybody who flies an airplane around here, if you go to a duty runway, you are going to get a sequence of numbers given to you in exactly the same order. They mean exactly the same thing, and they mean it anywhere you go in the world. Runway, wind, altimeter. They come out the same way every time, all the time. That is an example of controlled natural language, and that's what I'm getting at.
Yeah, unfortunately, when we are looking to find a root cause of something that happened in the past, with the fact that the system isn't there already, it's not standardized today, you have to do the text mining to find out the 7 different ways you can describe corrosion, right? If training got in place and standardization got in place and everybody got on the page years from now, you could get to that point. But right now, frankly, you have to use the text mining to figure it out, because it's just not that simple at this point. It's messy data, and getting through the messy data is a challenge.
So I appreciate you clarifying what you said, because again, I'm not the smartest guy, but now I kind of understand what you were saying. So from the vote collect point of view, because it's completely customizable, I think that's the word, George W. made it up, but where you can tailor exactly what the correct terminology would be on that type of deal. So if it was collective mind said, the term you utilize is corrosion, it is not, some other defect, right? So you can standardize that way, which again kind of leads to improving the quality of the write-ups and whatnot. So I can speak somewhat that where this has been used, like at Blunt and at Hill, they've customized that piece. So, to your point, right? Words mean things. Words matter. So it gets everybody on the same set of language, if you will, on conducting the checklist or the inspection. So.
Somebody else.
No other questions? Just first off, I just want to say thanks to all you gentlemen. Great presentations, and I know all 5 of your companies are working hard to solve really complex problems. I just 3 points, maybe a takeaway or just an observation. And I know we're working through some pretty significant issues right now, but the future, and some of you touched on the future. My view would be we need to fix right now before we move to the future, or else we won't have a future. So I know we're all in on several issues, but we really need your help on some of these current problems we face. And as I look down the row, I can name them, but I won't right now. And then I would just ask that you all help. For example, if you have an issue, or if somebody would have an issue with any subordinate unit of mine, you can come to me and I take responsibility. So one of the things I've learned is we all might want to do a better job as I sit in some of our deep dive meetings. Holding subs accountable is really important. Because as you do the forensics of a problem or a part, you find out that this sub works for you, that works down here, and he's got his own supply chain, and then we run down those traps. So I just, as we up the ante and as we talked about current focus today, I would ask holding subs accountable, because we all work with each other, right? And some of you are sub to another person, but you are the prime in another issue. U.S. government versus FMS. Interesting, emotional topic, probably better served with a drink ticket. But I would just tell you, our senior leadership is looking very hard with the current demand, what is going on with U.S. government, what we need versus FMS. And there's certainly an art and science to this, right? And understand direct commercial sales, et cetera, et cetera. But I would just ask for your leadership and because we got to work this together. If everybody knows why we send X amount of parts, because we're all in the same supply chain, essentially, in most situations, we all need to be in it together so everybody understands why. And we have certainly some white space or some gaps there too. Speed, accuracy, quality. I didn't mention it in the pitch up front, but the PM, cost, performance, schedule, got it. But speed, accuracy, which I equate to forecasting, and then quality is where we're trying to push at the current. And then, Mr. Ash, you mentioned something that triggered just a point, and just so to be clear for everybody, in the terms of the chain of command, because you mentioned ALC and the depot. The depot works for ALC, which works for me, so we're all one team, but there's a chain of command there, and we have some work to do in that area, but that's because ALC has to be value added for the depots. If they're not, then we had to have conversations. So just so everybody's tracking, and that's about it. But I appreciate your comments, and I appreciate your time, and appreciate what you're doing for our nation. Thank you.
That's it for us.
You got any more questions? Any more questions out here? Okay, it is now. No, it's not. Okay. Well, then I'm deaf. All right, it doesn't matter. Anybody got another question? Okay, going once? Going twice? All right, so first of all, I want to thank Howard Yellen and this great panel for the job you did today. Thank you so much. On time, on target, so that they can get to drinks as soon as I give them a couple of announcements. So thank you to the panel. Round of applause.